Hello everyone, I'm Avir. So today I'm going to present the research methodology courses final project presentation. So the topic that I worked on that one is digital twin enabled reinforcement learning for multi-objective path planning for autonomous vehicle. So here is the overview. The first one is the introduction, second one is the problem statement and objective. Then I discuss about the literature review, and I will discuss again the proposed methodology. After that, I will discuss about the expected result and conclusion. So as you all know that autonomous vehicles are very popular in this modern era because of its comfort. But in the past, the traditional based rule-based method were used, which is not efficient because of the roads complexity as well as the autonomous. There are lot of vehicles on the roads, so there from here the safety and efficiency concerns are arised. But uh, it is important that an autonomous vehicle can balance these two objectives at the same time, but they are very conflicting. So for this conflicting term, we can use the reinforcement learning to solve this problem. Then another challenge is we need to test the autonomous vehicles in different hazardful situations. But it is not possible in the real world because it is very costly. So digital twin can help us because it is a virtual replica of a physical layer. So from there we can easily test the vehicle's performance and deploy before deploy it in the real world. So our study is motivated to reducing the testing and training cost and propose an efficient driving agent. So as I said that safety and efficiency concern, what can be that concerns like collision avoidance, safe following distance, lane changing policy, response to unpredictable drivers, minimizing travel time, optimal route solution, reducing fuel or energy consumption. So as I mentioned in before that safety and efficiency are conflicting. So let's try to understand by a diagram. So here you can see this car have two choice. The first one is the shortest path, but it is not safe. But the second one is very safe, but the travel time is very high. So the question is, can traditional reinforcement learning solve this issue? The answer is no, because they only focus on the single objective, but multi-objective reinforcement learning can solve this problem by balancing the safety and efficiency. So what is digital twin and its role in the autonomous vehicle? So digital twin is a virtual replica of a physical layer uh, where it consists three different layer. That one is the first one is the physical layer, communication layer, and the digital layer. In the physical layer there have some sensors, data collection devices, and in the communication layer it contains the data transmission, policy and security and middleware. And in the digital layer they have the data preprocessing and analytics tools, models, and the visualization. So from the digital twin we can for by the digital twin we can create the situations, different hazardful situations and the efficiency situations, and we can test it in the virtually, so we do not have to spend our uh, testing testing cost in the real world. So it reduces the cost. So as I mentioned in the previous slides, that safety and efficiency for an autonomous vehicle is very important at the same time, but most of the time they are very conflicting. So the problem statement is how we can solve this problem, balance this two multi-purpose objective at the same time. And as we also mentioned that traditional reinforcement learning can solve this can solve only one problem, because they do not focus on the other uh, objective. So which algorithms are very efficient for this for balance this safety and efficiency. And the second one is the real world testing, which is very costly and unsafe. So how digital twin can uh, make this safe and reduce the cost. So here is our research objective. Uh, we are we are motivated to develop a multi-objective reinforcement learning framework for multi-objective problem and deploy in the digital twin for both testing and training purpose, which is cost efficient and safe. So here are some related work. In this related work you can see the paper 11 and paper 18 use the multi-objective reinforcement learning, but the limitation is here they do not use any digital twin. The algorithm that they use, that one is the involved q learning and the AWMRL. So we use in our study we use the involvement q learning, as well as you can see that in the paper 21 they demonstrate the DT during the training phase. So we also include it in our study. So no study actually combine all of these studies. So in this study we try to combine all of these studies. So this study is a quantitative uh, quantitative simulation based experiment study where we use the uh, Azure Digital Twin and Bing Maps for the roads, and we also use the multi-objective Q-learning. The sampling is it will automatically interact with the virtual environment, and the data collection is the collision report. Data collection is like collision report, travel time, path map. Here is the tools that we will use. The first one is the Microsoft Azure uh, cloud, where we will store the data. The Python libraries will be used for the reinforcement learning algorithm, develop the reinforcement learning algorithms. And in the Azure Digital Twin, we will create different virtual environment and we will test the autonomous vehicle driving agent on it. So here is our proposed method where we will use the Azure and Bing maps with different cities map, which will create an virtual environment on Microsoft Azure Digital Twin, which will provide the roads traffic, alternative routes, traffic lights, etc. as a parameter. So from these parameters, we'll create different hazardful situations and efficiency issues, which will be stored in the Microsoft Azure cloud, as well as from here we will define a current state. So when we will found the data in the cloud, we can retrieve it and we can train the model through the involved key learning model, and the updated model will be deployed in the on the Microsoft Azure Digital Twin Simulator. So when the autonomous vehicle agent will find its current state, it will pass the parameters to the deployed involve Q learning model, and from here, based on the algorithms, based on the model, it will find a feedback and it will take an actions. So if the actions is again hazard, creates an hazardful situations or any safety efficiency or efficiency issues, it will be again stored in the cloud. So based on the new data set, we can again train the uh, model using the involved Q learning model, and the updated model will be again stored deployed on the Microsoft Azure Digital Twin Simulator. So this loop will be continue the until it find the best solution. So it is our proposed method. Here is our expected result that we expect from this study. So first of all, study 11, we can it illustrate that the multi-objective reinforcement learning can perform better performance in safety and efficiency purpose, and also they can balance this conflicting problem, the multi-objective problem, as well as the second expected result is from paper number 21. They illustrate that during the if we use the digital twin in the training phase, then the model will learn so quickly and it will perform better. So it is our second expected result, as well as the third one is it will reduce the time and improve the route completion rate around 13 to 27%. So here is our overall discussion. The first one is using the digital twin, we can reduce the testing cost, as well as we will produce a large amount of data set, because since we using the digital twin as testing and training purpose, so from the both side we will get the data and it will be stored in the cloud. So this will be a valuable resource for the researchers. They can research on this data set. The third one is most important. That one is multi-objective problem solve. So since we told that safety and efficiency are both important at the same time for the autonomous vehicle, but they are conflicting. So using the reinforcement learning, we can easily solve this problem, and we also discuss about how it works, like multi-objective reinforcement learning can solve this problem. So in the conclusion part, we can say that combining the digital twin and multi-objective reinforcement learning, such as the involved Q learning, can create a safe and faster, smarter autonomous vehicle agent. So the future work can be, we can use the other multi-objective reinforcement learning that is used in different previous studies, and we can compare that. So here is the references. So thank you everyone.